Hello, welcome to another class. Let me check if it's working here. Is it third time I'm trying? Because Chrome was not working fine in my Linux. Let's see if now it's better. Okay, looks like it's working fine. There is a new YouTube UI for live videos. And maybe that was the reason, but let's see. Okay, let me test find my Linux. Let's see if now. Okay, everything looks good, sorry. And in today's class, we will fix a big issue that we had, that was our password was being saved in the database as plain text. And that is something that we should never do it. I only did because we are building up the application, and one of my goals is to show mistakes that probably beginners will do, and then we don't do those mistakes ever again. So the first thing I will do today is I will make sure that let me close this. I can go here to see our containers, and I will make sure that our Postgres is running. I will start it. So we don't need the other ones for today's class because we will be doing some change, and I do like the let me go to documents, and then I guess it's code up data front end first, and then I copy this to make my life easier. I open new tab, and then I go to this folder. That will be the backend. Oops. Oh, when open, I can just do something like this: cd app, and then backend. So as we know, here we run the npm run dev. Oops, what is wrong here? Oh, I forgot. We need to run this guy as admin, right? Yeah, because we are running port 80. I forgot about that. So I can just do sudo. Okay, so we are running port 80. I think you all remember this because as we set up to run in port 80, that is a default port for web service, my Linux configuration is asking me to make as a super user, is that I have to use the su command. And in this case, he is just .NET run. Now we should have application running from those terminals. This is the backend. There's like a web server for the backend. This is the the web server for the front end. Later on, I'll give some more details on this. I hope everything is working fine because I'm seeing this message. But since I changed my internet provider for a wireless one, it's not that good. But let's see. I hope it's going to work. So we now have this application. And as you remember, when you are doing a sign up, that we put something here like best x121 at noemail.com, and then we put a password here. We're going to improve this later on as well. We should not allow passwords in sequence. I put 1, 2, 3, 4, 5, 6, and I will sign up. And the thing is, if we go to our database, so I will connect to our database, we have a big security flaw here. So if you open, and then I maybe open a new query, where is it? Database, this is IPVira, new query, and then if I select everything from users, this one here. Select start from user. This is not good because anyone now know the password. Just need to select the table. So our goal is to use some encrypting tools. I don't know yet which one we're going to use. There is plenty out there. You use AI to help us on that and maybe do some learning. So that is our goal. Our goal is that we use a password that, encrypting that given a password, we apply this encrypting and then you get a new value. The idea is that we will store that encrypted value, so like a key. Every time you do authentication, we will ask the user for the original password because we never know that one. We're going to apply this encrypting and then we're going to compare to what we have in the database. But we will choose one that is impossible to get the encrypted one and go back to the original one. Don't ask me to prove you all the details. It's something very complex, but we can ask some more things. So let's start here the prompting thing. I said, I need to improve security. Sometimes I don't need to do this extra. I like because we train communication by encrypting the password. What are the options that are secure, and used for professional applications. Let's see what is coming from there. But remember, this is something important to have in mind. We should know at least high level what we're looking for. Otherwise, the AI is going to drive us. And then we're not going to build what we want anymore. We're going to build something that AI is going to do. So let's see here. For professional application, security password hashing options that are in the system. So this is the idea of hashing. Hashing is a technique that we get a value, a string that we know, and we apply a logic that is going to convert to something. Every time we apply that logic, we're going to get the same hash. So we can compare to see if the hash applied for the value that the user is giving is the same as the one that we have in our database. But we can never go back from that hash value to the original one. Okay, so here there is some recommendation in order of preference. So there is a list, winner of password hashing competition 2015, bcrypt barrel test in while adopted, script memory hard algorithm. For your .NET application in your C# backend, I recommended Argon 2, so this is the winner, via this Continuous Security Encrypt Argon 2 NuGet package. Bcrypt via this one. Critical points. Never encrypt password, always use one-way hashing. Okay. Always use a unique salt per password. Modern libraries handle this. Use high-cost interaction parameters, but balance with performance. Store algorithm cost salt in your database. What you like me to implement? One backend, I recommend bcrypt for simplicity and improved reliability, or Argon 2 for maximum security. Let's see, what is the most used one for .NET Core applications? And of course, we can later on decide to use a better one, but just to give you the idea. Bcrypt is the most widely used password hashing solution for the core application. In fact, it's turned because mature and barrel test 20 years in production, simple API with sensible defaults, automatic salt generation management, wide adopter across .NET ecosystem. Okay, so it's taking more secure, okay. And I say, okay, let's use BC Crypt. BC is like that, bcrypt, so bcrypt. Please change the user controller to support it. Let's see how it goes. And remember, you can always come here and see which change are being made, and then you can validate before you accept. If you don't like, we hold back and you ask again. Let's see. So we will install this in our backend application. I will allow it to do. So another option is I could go to the website, get how to use it, but here I'm leveraging AI to do it for me. I'm paying $10 a month, so I'm gonna make it to work. Okay, looks like it's there, and then it's working. Now it's going to update the controllers. I keep for now, because if I don't like, I can just revert. So in the controllers, I see that, see, we are using that new thing. Let me keep this so I can see everything already. So Don, I have updated your password, change made. Added the big imported. So it's always good to have this, because sometimes it's nice to use this. So we're gonna put in our PR. So now let's see what changes are made. The was important. And then right here, instead of just get the password from the request and use it, we are using this bcryptnet hash password. It's a very simple thing that make a big difference now. So then I'm gonna say, okay, let me save this. Oh, actually it's already saved. So I'm not sure if this guy will automatically get the difference. Probably not. We can make, let's try. I know that the front end will get it, and the back end not sure. But what we can do, let's come back here. Let's do another sign up, and let's see. Test encryption, no email.com, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now let's go to our database and let's see what is in there. Oh, it's already in this window. So we got now that we have to stop our application and rerun. I know there is a way to keep watching. I guess here there is a watch. We can put that later on. But let's rerun. Okay, so let's go back here. Oh, sorry, not this one. I'm mad with Google Chrome because it's not working for me. And now let's do a new sign up and then test encrypting at 2 at noemail.com. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now let's see how it goes. Yes, see, that was our goal. Do you remember when we create the password field that we thought, oh, what should be the length of this field? And we could use maybe 10, 20, 15, but I asked that time, what should be a good size if later on we do encrypting? So this is something that is important for us to sometime have in mind when we're going to create tables, what the length of those fields. And if we can validate up front with the business, as we can see, like this guy, let me go here and see the script as create. So we put the email and the password with 255 positions. Good? Because I was already anticipating this change. If we had put only 10, then we have to increase. Otherwise, we will not be able to store this encrypted password. If we want to do some testing, for example, let's go to our application and I'll put like encrypt one at noemail.com. I'll copy this. Let's put the password. Now I put 654321. 654321. So if we go back to our database and then we run this, as we can see, there are some similarity. But this is all different because it's like a calculation that happened that get our 1, 2, 3 or whatever password we give, apply some logic, and then generate this number. There is no way that we can go from this back to the original one. Or maybe if there is, it's very hard. What can happen is if someone has access to your database, it can try to break the password by providing some password and compare. For example, we usually know that the database, there is someone that put the password 1, 2, 3, 4, 5. And then someone can say, oh, let's encrypt 1, 2, 3, 4, 5, and then see what is in here. But this API try to use some seed that they use to make it harder for this. Because if two users has the same password, they will have the same hash. Let's see if that is true. Let's do this. I'm gonna do another user here that I will call encrypted2. And then I'll put the same password again, 654321. 654321. And then I'll save it. So in theory, we should see the same hashing for both passwords. But look what happened. They are kind of different. So I can ask, let's see if we can get a glimpse how this hash works. Can you explain in a very simple way so a beginner can understand? I created two users with the same password, but I see different hashes in the database. How that happened? Great question. Here the encryption works simple. The magic of salt. When you hash a password with when you hash a password with basic encrypt, it does three things automatically. Generate a random salt, a unique handle string for each password. Combines the salt with your password, hash them together using the bcrypt algorithm. Why different hashes for the same password? Even though both users has the same password, example password 123, bcrypt generates a different random salt each time. So for example, this is our password and there is a random salt here. So that's why it's going to have some difference in the hashing. Different salts, different hash, even with identical password. Why is it important? Security. If someone steals your database, they can't tell how does login and then how does login work then. The salt is stored inside the hash string itself. So here that random thing is stored. So when verify, extract the salt from the stored hash, hash the entered password with the salt, compare the result. For example, the email has to be different. So when we get the password for this guy, we'll get this. The salt that is randomly generated is part of the thing here. And then this salt will be applied to encrypt the password that is coming to compare with this one. So now it's kind of, we have a unique like hashing for each one, because in theory, hashing, we could have collision. So the salt thing, the idea is to avoid this collision. I confess that I'm not like deep into the encrypt, that the point that I could explain everything that happened here. But if you want to understand, you can have a conversation, ask for some more documentation. I'm a believer that this is working so far, so you can trust it. This why basic encrypt is so clever. The salt is built into the output, so you don't need to store it separately. So in our hash, the salt is in here. So when we say, oh, I want to compare this password with this, we already get the salt here, and then we can get back. So now we'll make harder for someone that has access to the database to figure out, even if he find one password, imagine that someone has 1, 2, 3, 4, 5, 6. If there is no salt, the attacker will know all the other password that was 1, 2, all the other user that has password 1, 2, 3, 4, 5, 6. Okay? I hope it didn't confuse you, but that is the idea. We are making our application way more secure, use something that is in production for over 20 years, I think is what is said here, 20 plus years. There are different ways to do it, as we could see there at the beginning. And based on our conversation, we decide to go with this one. If we want to go deeper, I'd say how a hacker could break passwords generated by, password in this case. If you want to go deep, like for sure someone that is a cybersecurity specialist, they know way more ways. Maybe there is tools, there is ways. So it's nice to do some research. So the only way is brute force. So brute force means they have to be trying, they have to have access to a database, we get the emails, and then they're gonna try multiple times. Brute force usually, if you put some rules in the password, like we should never have a password like sequential 1, 2, 3, 4. We're gonna add this later on. For example, cannot be in sequence, must have one uppercase, one lowercase, and one special symbol. This is the most common rules out there. So as you can see, it's impossible to break in another way than by brute force. And this is why it's so slow, good for us. BC encryption is intentionally slow. Each guess take like 1/3 of a second, 300 milliseconds. That is only 3 to 10 attempts per second. That means if your password has like some security, it will take a lot of tries to find something. So this is already security enough. My son was giving me some numbers because my son is specializing in cybersecurity, and there's something like this. For example, a weak password, only 8 lowercase letters. That means 26 power 8, so that is 208 billion combination. If we do like 10 attempts per second, it will be around 606 years. So it's possible. It's guaranteed by brute force that one combination one day will come up, but maybe it will take too long. People say that with the quantum computers, this can change drastically, but so far it's not reality. If we go to a strong password with like 12 mixed characters, look, I don't even know how to say this number. So it's kind of million, billion, trillion, quadrillion, pentillion. sextillion. Those is that why they say basically impossible. So what we did here is something that is fantastic in software engineer. Our application basically changed only 2 lines. We imported a library, and then we use that library to encrypt. And we brought to our solution a high level and almost unbreakable password protection. So to be able to do this, a lot of people, intelligent people, smart and hard work, had to do this work so you can use it for free. I forgot to ask here, but say, oh, is this Bcrypt open source and free? It's very important to check. Otherwise, you may be using something that when you go live, you may have to pay something. See, so we could go there to get some more details. So is what I like to tell people. Before you start to feel proud and super smart, pay attention to how much stuff is out there so we can do our work. So if you want all the details possible, is here. It just show how easy it is to use. And then you can see how active they are. So look, is a 959 stars in the repository. Let's see if there is some numbers here. So this is people that is using it. Of course, it's C#. There is some Java as well. I don't know, maybe they port for that as well. Sometimes those libraries, they are putting many different, so it's an open source, MIT license. And that is it. Be careful, because sometimes we could be using something that is not that good. So it's always good to come to the repository and take a peek. See who is there, if something that is on the road for a long time already. So, for example, let's see the activity here, how it goes. As you can see, there is movement here. There is thinking happened like 27 days ago. So it's not something that was forgotten and no one is taking care anymore. Cool. Yes, so that was the plan for the today class. And another talk is how important it is us to have an idea what we need. Because when we ask the Copilot to create that controller for us, maybe it could suggest us, oh, you are storing a plain string in the database, a text in the database. It would be wise to encrypt it, but it did not. Maybe another prompt, another day, we could get a suggestion. So if I use a different agent here. So maybe there is one agent here that is more like focus on cybersecurity that will tell us that. So those mistakes is going to be part of some solution we get from the AI. So it's up to us to validate it. So from now on, whatever is important, we're going to review the code and make sure that it makes sense. And I am very glad that we can just do a little change and then boom, we have something magic happening. That is a part of abstraction, the power of abstraction. We just gonna use it. We know what is the idea and how to use. All the details, we have no idea, but we can take advantage of it. Cool. Okay, so that was the goal of the today class. I hope you enjoy it. And later on, we're gonna do the login, and then you see how can we, validate a user based on those passwords. Remember that now everything here make no sense anymore, because that is something that happened. When we change our application, sometimes we have to clean up the data. Because if we went live and we have those passwords stored as plain text, we will have to build a tool to convert all those passwords. Otherwise, when we implement our login using the new thing, we're going to have some trouble here. Or we could maybe do something, have a flag to say, or even analyze, this password is already encrypted, let's decrypt. If it's not decrypted yet, you just use it or encrypt it and then use. That is how, maybe imagine that you have a system, have billions of users already, and then you are change how we are encrypt the database. Sometimes you cannot do just one go, so you have to plan to do that. In our case, we are start from the scratch. We can just delete everything and start again because everything here is sorted. So we could just come here and say something like delete from users where ID is more than 47. A company that has sorry, I don't want to use you, my friend. Go get away. If a company that has customers already has to plan for this because they cannot delete live data from user. Now we are only with the last one. Oh, sorry, I forgot the equals here. Those are some mistakes that we do, which, is this, I got smaller, but I forget that one, and we miss one data, and maybe there is a bug because we didn't delete everything we need. So, of course, later on we're going to drop this table and recreate, so it's not a big deal. Cool, and I hope you enjoy it, and it's something very interesting that every software engineer should know. We should never, ever store a plain text password in a database. And don't try to do the encrypt yourself because it's not something easy. It's a lot of work to make it right. And let's take a leverage what is out there already. Okay, so thank you. God bless you. Till next class. To do the encrypt yourself because it's not something easy. It's a lot of work to make it right. And let's take a leverage what is out there already. Okay, so thank you. God bless you. Till next class.